Imagine for a moment a technology that limits carbon dioxide emissions from dirty coal and gas combustion and produces clean hydrogen gas in the process. Imagine a technology that arose from observing nature and is mainly natural. Hello and welcome to this brief, albeit different, talk on climate change and carbon dioxide emissions. The technology that limits emissions from dirty coal and gas combustion exists today. It produces clean green hydrogen gas by utilising knowledge of carbon dioxide reactions in nature, under pressure, at depth in the ocean. There is a saying among scientists that we know more about the surface of the moon than we know about the ocean's depths. In relation to climate change, we know more about carbon dioxide in the atmosphere than we know about carbon dioxide in the ocean. This is true particularly of carbon dioxide dissolved under pressure deep in the ocean. The ocean covers 70% of the Earth's surface and acts as an enormous carbon dioxide sink because carbon dioxide is 50% heavier than air and falls from the atmosphere to the ocean. Then, due to a slight charge resonance within the carbon dioxide molecule, carbon dioxide dissolves in ocean water. Carbon dioxide gas is about 40 to 50 times more soluble in water than oxygen, and there is 50 times as much carbon dioxide dissolved in the ocean now as there is in the atmosphere. Now, carbon dioxide in the ocean may be out of sight and therefore out of mind, but when carbon dioxide dissolves in the ocean, it becomes hydrated by water, and some of this hydrated carbon dioxide gas forms carbonic acid. This carbonic acid slowly acidifies the ocean. According to the experts, ocean acidification is increasing slightly each year and is worldwide. Now, the more carbon dioxide in the atmosphere, the more carbon dioxide dissolves in the ocean and the more carbonic acid is formed. And within limits, the deeper the ocean, the greater the pressure and the more carbonic acid is formed. This is a valuable observation for the commercial production of hydrogen gas and is discussed later. The carbonic acid formed from carbon dioxide reacts with calcium carbonate and other carbonates in the ocean. These carbonates break down and become unavailable for biological use. In other words, the level of ocean carbonates decreases in the presence of carbonic acid. The decrease in carbonates makes it difficult for ocean organisms to make calcium carbonate structures such as shells and skeletons. Many of these organisms are at the base of the ocean food pyramid. Much of ocean life ultimately depends on them. There is nothing new in all this information. It is well described in science journals, including the top US journal Science, and in reports from the Intergovernmental Panel on Climate Change. However, there has been invented, patented internationally and developed a new process of decreasing carbon dioxide emissions into the atmosphere, coupled with the production of clean green hydrogen gas. In addition, coupled to this process is the possible production of bicarbonate in sufficient quantities to reform carbonates and potentially reverse ocean acidification. This new process involves carbon dioxide gas emissions from fossil fuel combustion and cement production placed under moderate pressure in water to split water molecules into their component hydrogen ions and hydroxide ions. This is equivalent really to carbonic acid production in the ocean at depth, but with much more carbon dioxide. The large concentration of carbon dioxide results in a large production of hydrogen ions, which are the basis for the production of hydrogen gas. The large number of hydroxide ions formed can react with carbon dioxide to produce bicarbonate if the process is taken to completion. If the process is limited, then oxygen gas is formed. The pressure used is generally more than 10 atmospheres, which is equivalent to the pressure at more than 100 metres below the surface of the ocean. This pressure can be achieved quite economically and is reached or surpassed in various commercial enterprises. In the process invented, the large amount of hydrogen ions that have been derived from the splitting of water by carbon dioxide under pressure can be converted to hydrogen gas using low amounts of electricity from renewable energy sources. Indeed, the hydrogen gas can be utilised as a means of storing renewable energy. Note that the water molecules are split by carbon dioxide under pressure, not by electricity as occurs in a standard electrolysis unit. This makes the hydrogen production relatively cheap, especially as it is partly under pressure. So, a useful and green commercial product can be produced by the process. With the process just described, coal and gas combustion and cement production have just become potentially massively cleaner. Ocean acidity may decrease, and we can limit carbon dioxide emissions economically until the Earth transitions to renewable energy. Well, thank you very, very much for listening and watching. My name is Dr. Russ Beckett. I'm the Research Director at UGB Hydrogen.